Okay, now we are provided with a formulation. Okay, so we need to determine um, the number of milligrams of sodium chloride that would actually make the solution isotonic. Okay, and so we have here ephedrine sulfate with an E value that is 0.23, its amount, and according to the formulation, we add a sufficient quantity to make, okay, an isotonic solution. Okay, so you are asked to determine how many milligrams of sodium chloride should be used in compounding the prescription. Okay, so what are you going to do? And so remember that E value is basically the number of grams of sodium chloride, um, the number of grams of sodium chloride represented by 1 gram of the substance. Okay? And so that is what the E value means. Okay? It is the grams of sodium chloride that is represented by a gram of the substance. Okay? Now, we are going to make an isotonic solution. Okay? What is an isotonic solution? Okay, so always remember that an isotonic solution contains 0.9% of sodium chloride. Okay, yeah, so an isotonic solution is a solution that contains 0.9% um, sodium chloride. Okay, so paano natin nasabing 0.9 percent sodium chloride? Okay, so remember that um, we can compute for the weight of the substance that will make your solution isotonic by using this formula: 1.86 degrees Celsius times I divided by 0.52 degrees Celsius equals the molecular weight of the substance. So we say 58.5 for sodium chloride divided by X being the weight of that substance. Okay. So the I value of sodium chloride is by default 1.8. Okay. So we simply solve for the value of X. Okay. And so to make an isotonic solution in a kilogram of the solvent, okay, we would need how many grams of sodium chloride. Okay. And so we calculate for the value of X. Okay. So that will be equal to 58.5 times 0.52 divided by 1.86 divided by 1.8. So that will be equal to 9.09 grams. Okay. So meaning to say 9.09 grams in 1,000 grams of water will make a solution isotonic, assuming that the 9 grams of sodium chloride do not add to the total volume of the solution, then we actually have a solution that is 9 grams of sodium chloride in 1,000 milliliters of the solution. Okay? Now, its percentage is equal to 0.9%. Okay? So that's how we actually got 0.9% sodium chloride as an isotonic solution. This is also known as the normal saline solution or the NSS. Okay? Normal saline solution or the NSS. Now, because we want to prepare 30 milliliters of sodium of an isotonic solution containing ephedrine sulfate, all we have to do is to determine how many grams are supposed to be present in 30 milliliters of the solution. Now, if the isotonic solution is 0.9%, it means zero point 0.9 grams of sodium chloride per 100 ml of the solution times 30 ml of the solution. So zero point 0.9 times zero point 0.9 times 30 divided by 100. This will be equal to 0.27 grams. Okay? Yeah, so 0.27 gram of sodium chloride are needed, okay, to make an isotonic solution. However, our solution does not contain only sodium chloride. Okay? It also contains ephedrine sulfate. Okay? Mayroon pang iba pang substance that contributes to the tonicity of the solution. Okay? So we have to consider the contribution of that particular drug to the tonicity of the solution. Okay? Now, how do we do that? We do that by determining the equivalent sodium chloride nitong zero point 0.3 gram of ephedrine sulfate. Okay? So remember, E value is grams of sodium chloride per gram of the substance. Zero point 0.3 gram, this is your ephedrine sulfate. We multiply to it 0.23. Okay? 0.23 being grams of sodium chloride per gram of ephedrine sulfate. Okay? So 0.3 times 0.23 will be equal to 0.069 gram of sodium chloride. So this is the amount of sodium chloride represented, okay, by the ephedrine sulfate. Okay? Now, if we want 0.27 gram of sodium chloride in the solution to make it isotonic, and ephedrine sulfate represents 0.069 gram of sodium chloride, then the amount of sodium chloride that will be added, okay, to make the solution isotonic is only the difference between 0.27 and 0.069 gram. Okay? And so the answer should be 0.201 gram. This is the amount of sodium chloride needed to make the solution isotonic. How about this one? It's the same, it's a similar problem, okay? Yan. So we have anhydrous dextrose, 2.5%, sodium chloride, QS, so meaning to say a sufficient quantity to make the solution isotonic, okay? Now the difference here is that the E value of dextrose is not given, okay? But instead, the molecular weight of dextrose is given. That being said, we can actually determine for the value of E of your dextrose. Okay? So the E of dextrose is equal to 58.5 divided by 1.8 times. Remember that dextrose is a non-electrolyte. Its I is equal to 1. And the molecular weight is equal to 180. Okay? So the E value is 58.5 divided by 1.8 times 1 over 180. Okay. So it should be equal to 0.181. Okay. 0.181 gram sodium chloride represented by 1 gram of the dextrose. Okay. Or 0.1806 gram. Okay. And so anyway, we will not actually be um, rounding this off. Okay. And so that's the E value of your dextrose. Okay. Next is how much. Okay. And so the first step is to determine how much of sodium chloride are actually needed to make isotonic solution. Okay. Now, since we have 1,000 milliliters of the solution, so 0.9 gram per 100 ml, this is the 0.9% times 1,000 ml. So this will be equal to 9 grams. So we would need 9 grams of sodium chloride to make the solution isotonic. Okay? The next that you will compute, dito na lang sa baba, okay? How much sodium chloride is represented by dextrose or by any other substance that is contained in the preparation. Okay? Now, since we have 2.5% of dextrose and hydrous in a liter of the solution, we need to compute first the amount of dextrose in the solution. So that is 2.5 grams per 100 ml times 1,000 milliliters. So this is equal to 25 grams. Okay, so there are 25 grams of dextrose in 1,000 milliliters of the solution. Now we are not yet done because because the step number 2 is compute for the sodium chloride that is represented by the substance present in the solution. Okay, so 25 grams times its E value, this one, and so 0.1806. So this will be equal to 4.514 gram. This is the amount of sodium chloride represented by the dextrose. Okay. The step number 3 is deduct. Okay. Ayan. So i-deduct ninyo yung amount, okay, of sodium chloride represented by the dextrose, okay, to determine the amount of additional sodium chloride to be added to make the solution isotonic. Okay, and we need 9 grams of sodium chloride minus this one, 4.514 grams of sodium chloride. So the final amount of sodium chloride is 4.486 gram of sodium chloride. This is the amount needed to make the solution isotonic. Okay? And so moving on. And so let's have another example. Now, there are some cases where sodium chloride cannot be used as as a tonicity adjusting agent. Okay? And so what are these occasions where sodium chloride cannot be used as a tonicity adjusting agent? For example, you have a certain medicinal agent contained in the solution that does not react well with sodium chloride. So meaning to say, hindi siya inert, okay, with sodium chloride. Okay, so you need to use another tonicity adjusting agent in order for you to prepare an isotonic solution. Okay. Now you may ask, sir, why don't we just adjust the amount of the drug itself to make an isotonic solution? Yes, you can do that, but remember that the solution should contain a specific amount of the drug. Okay, and that is that is the strength of the solution. Okay, the strength of the solution is always dependent on the amount of the active ingredient that is present in the solution. Okay, so sometimes no, you cannot simply adjust the amount of the drug itself to make the solution isotonic. Okay, yan. Kasi pwede kasi na masyadong mababa yung tonicity that is contributed by the drug. Okay? So you need to add another substance that will increase the tonicity of the solution um, to make it isotonic. Okay? Yeah, so this is an example of a problem that includes boric acid, which is a tonicity adjusting agent. Boric acid instead of sodium chloride was used as a tonicity adjusting agent. Okay, so again, we follow the steps. Okay, that we are going the steps. No, yeah. So yung steps na ginagawa natin. So the first is compute for the sodium chloride that is required. Okay, so 0.9 gram per 100 ml and times 30 milliliters. So again, this is equal to 0.27 gram. Okay, so this is the amount of sodium chloride required to make the solution that is 30 ml isotonic. Okay, the next one is we determine um, the sodium chloride contributed or represented by the drug. Okay, now how do we do that? We need to know the E value of your zinc sulfate. Okay, yeah, so we will compute for the E value of zinc sulfate. So the E value is 58.5 divided by 1.8 times um, the I value of your zinc sulfate 1.4 divided by its molecular weight, this one, 288. Okay, so the E value is equal to 0.158. Okay? And so 0.158, that's the E value of your zinc sulfate. Next is, we simply multiply this amount by the E value of your zinc sulfate. Okay? So we have here, dito na lang. Yan, 0.06 gram of zinc sulfate times 0.158. This is equal to, yan, napakaliit na amount, 0.009479 gram of sodium chloride contributed by zinc sulfate, okay, in the solution. Okay? The next step, ayan, yung next step natin kasi ay deduct. Okay? Kaso we cannot simply deduct. Actually, we can deduct. Okay? So, sige, let's move on. So, i-deduct natin 0.27 gram of sodium chloride minus this one, 0.009479 gram of sodium chloride. So the amount of sodium chloride that will be needed is 0.26052 gram of sodium chloride. Okay? Now, the tonicity adjusting agent is not sodium chloride. It's boric acid. So we need to compute for the E value of boric acid. Para hindi kayo malito, lalagyan ko to ng boric acid. So, E value of boric acid is equal to 58.5 divided by 1.8 times the I of boric acid, which is 1, and the molecular weight of boric acid is 61.8. So, that is equal to 0.5259 or 0.53. No? Kinompute na natin to kanina. Okay? So, remember that this is grams of sodium chloride represented by 1 gram of boric acid. Okay? Now, you have this amount of sodium chloride needed to make the solution isotonic. Okay? But according to the problem, you need to add a sufficient quantity of boric acid to make it isotonic. Okay? So, we will need to convert this to boric acid. Okay? Now, to convert that to boric acid, yan, notice gram sodium chloride per gram of boric acid. So we will simply divide this by this. Okay? So the amount of boric acid will be 0.26052 gram divided by 0.5259 gram. This is grams of sodium chloride. This is grams of sodium chloride per gram of boric acid. So we cancel the grams of boric acid, the grams of sodium chloride to get the grams of boric acid. So it will be equal to 0.4954 grams of boric acid. Okay, so that is our final answer. Okay. And so how about this problem? Okay. So it's the same actually, no? And so if you will look at this particular problem, we don't have sodium chloride in the formulation. We have potassium nitrate. We have silver nitrate, which is our active ingredient. Okay. The difference is that instead of giving us the exact amount in grams, we have the weight of the drug in percentage, or the amount of the drug in percentage. Okay. Yeah. So once again, that's what we are going to do. No, we do the steps. Okay, so the first step, compute for the amount of sodium chloride required. Okay, to make an isotonic solution. Okay, yan. So ito na naman si point 9. Okay, 0.9 grams per 100 ml times 15 ml. Ayan. So 0.9 grams times 15 divided by 100. And so this is equal to 0.135 gram. Okay, so this is the amount of sodium chloride that will make the solution isotonic. Okay, the next step that you will do, so compute for the sodium chloride contributed by the drug, by the active ingredient. Okay, so we have 0.5%, which is 0.5 gram per 100 ml times 15 ml. So this will be equal to 0.075 grams of silver nitrate. Okay? Ayan. Now notice that our active ingredient is silver nitrate. Well, we know na silver nitrate cannot really be adjusted, okay, by sodium chloride. Otherwise, when you add sodium chloride to your silver nitrate, yan, there will be a precipitate of silver chloride produced, okay, which will reduce the amount of the silver nitrate. Now, the silver nitrate is actually an antimicrobial agent that is used to treat as that is used as a prophylaxis for neonatal gonorrhea, which is an infection of a newborn child. Okay? Yan. Kasi kapag normal yung delivery of a child, okay, the neonate will pass through the birth canal. Okay? Yan. So to avoid any complications of gonorrhea, which is actually blindness. Okay? Normally, the newborn child, is given antimicrobial eye drops. Okay? At ang usual na ginagamit na antimicrobial eye drop ay silver nitrate. Now, because it is an eye drop, no, the eye drop should be isotonic. You cannot use sodium chloride. That's why we use potassium nitrate instead. Okay, yan. So, kaya ito yung dahilan why we don't use sodium chloride as a tonicity adjusting agent in this case. Okay? But we are not yet done. So we are just computing for the sodium chloride that is contributed by the active ingredient. Now, what else do we know? We don't know the E value of silver nitrate. So we will need to determine the E value of silver nitrate as well. Okay? So the E value is 58.5 divided by 1.8 times. Ayan, tingnan natin dito. Sabi dito, silver nitrate is a 2-ion electrolyte with 80% dissociation. Okay? So ibig sabihin, its I value is also 1.8. Okay? Divided by the molecular weight of silver nitrate, which is stated here, 170. Cancel this one. So we have E value of silver nitrate, which is equal to 0.3441. Okay? Yan. So we have the weight of silver nitrate. We have the E value of silver nitrate. We simply multiply these two. Yan, lipat ako dito. So 0.075 gram times 0.3441. This is equal to 0.0258 grams of sodium chloride. This is the amount of sodium chloride that is represented by 0.075 gram of silver nitrate. Okay? Next that we will do is we will determine the amount of sodium chloride, okay, that will be needed. Ito yung deduct. Ito na yung deduct phase. Okay? Ayan. So we have 0.135 gram of sodium chloride, which will make the solution isotonic, minus 0.0258 gram of sodium chloride. Okay, so 0.135 minus 0.0258 gram is equal to 0.1092 gram of sodium chloride. Okay, now, because we will not be using sodium chloride as a tonicity adjusting agent, we will still need to convert this to potassium nitrate. To convert that to potassium nitrate, we need to know the E value of potassium nitrate. Okay? So the E value of potassium nitrate is equal to 58.5 divided by 1.8 times the I. Okay? The I of potassium nitrate is also 1.8. It is a 2-ion electrolyte, 80% dissociation. 1.8 divided by 101. So this will be equal to 0.5792. Okay? So that's the E value of potassium nitrate. Now, to determine the amount of potassium nitrate, we simply divide 0.1092 gram by 0.5792. And this will be equal to 0.1885 gram of potassium nitrate that will make the solution isotonic. Okay, so the E values are actually in a table. Okay, so you can actually look for a table of E values in your textbook. The E values are there, no? And so most of the time you don't actually need to compute for the e-value because the e-values are already stated in the book, or they are in a table. Okay. Now, aside from the e-value, we also have the freezing point data that can be used to determine the amount of sodium chloride to make isotonic solutions. Okay. So normally we have a table of values for the freezing point depression of 1% solutions of certain drugs, including sodium chloride. So take note that that 1% sodium chloride has a freezing point depression that is equivalent to 0.58 degrees Celsius. Okay, and we can use that, okay, to determine the amount of sodium chloride that will make an isotonic solution. Meaning to say, a solution that has a freezing point depression that is equal to 0.52 degrees Celsius. Okay, so how are we going to use the freezing point depression? And so para lang ipakita, okay? And so over here. Anyways, bago ang lahat, before I proceed to this, and let's again compute for the amount of sodium chloride that will make an isotonic solution. Okay, how do we actually make use of the freezing point data to determine the amount? Okay, the amount of the drug. Okay, that will make an isotonic solution. Yeah, so basically, ganito lang yon. Okay, so 1% of sodium chloride has a freezing point depression that is equal to 0.58 degrees Celsius, right? Now, if we want to make an isotonic solution, then the freezing point depression should be equal to 0.52 degrees Celsius. Okay? X means this is the concentration of sodium chloride that will make an isotonic solution, or a solution having a freezing point depression of 0.52 degrees Celsius. So we simply look for the value of X. Okay? Ayan. So move this here, move this here. Okay? So we have 0.52 divided by 0.58. Yan. So your answer should be equal to 0.8966 and degree percent, okay? Or 0.9%. Okay? So diyan ang galing, isa pang dahilan, okay? This is how you will show the freezing this is how you will show that the isotonic solution is indeed 0.9% sodium chloride. Okay? So ito yung use ng freezing point depression values. Okay? We simply use ratio and proportion. Okay? Ayan. So now let's incorporate sodium chloride in a formulation. Okay, so what if present siya in a particular formulation? Yeah, so for example, in this particular problem, you are asked to determine how many grams of sodium chloride should be used in compounding the prescription. Okay, so again, we have steps. Okay, yeah, so the first step is to deduct. Bakit agad deduct? Okay, yeah, so bakit agad deduct? Okay, so deduct meaning to say deduct the freezing point depression contributed by the drug, okay, present in your formulation. Okay, remember na the isotonic solution should have a freezing point depression that is equal to 0.52 degrees Celsius. Okay, now propane hydrochloride has a freezing point depression that is 0.12. Okay, if its concentration is 1%. Now, our propane hydrochloride is present in the solution as a 1% strength. Okay? So, ibig sabihin, the freezing point depression contributed by this drug is 0.12. Okay? So, we deduct this, 0.12 degrees Celsius. Okay? So, this will be equal to 0.40 degrees Celsius. Okay? So, this will be the needed, okay, freezing point depression for your sodium chloride to make an isotonic solution. Okay? Now, what else do we know? We know that 1% solution of sodium chloride has a freezing point depression that is 0.58 degrees Celsius. what is the percentage of sodium chloride X that will produce a freezing point depression that is equal to 0.40 degrees Celsius? Okay, so X will be equal to 0.69%. Okay, now what you are being asked is the number of grams of sodium chloride in a 100 ml solution that will make an isotonic solution. Okay, so that's step number 3. Okay, so this is 0.69%, meaning to say 0.69 grams per 100 ml times 100 ml, the volume of the solution. So the amount of sodium chloride that will make the isotonic solution is 0.69 gram. Okay, so how about this one? Yeah, so this time we don't have sodium chloride, but instead we have boric acid, okay, to be used as a tonicity adjusting agent. Okay, we have 1% of homatropine hydrobromide with a freezing point depression that is 0.11. Okay, now remember, step 1 is the duct. We need a freezing point depression that is 0.52 degrees Celsius to make an isotonic solution. But the drug, the 1% drug, okay, contributes by this amount, 0.11. So we deduct from it 0.11 degrees Celsius. Okay, so this will be equal to 0.41 degrees Celsius. So this is the amount of, this is the freezing point depression that will be supplied by the boric acid solution. Okay, the second step is we will compute for the amount of sodium chloride that will provide a freezing point depression that is 0.41 degrees Celsius. Okay, so once again, we go back to this 1% has a freezing point depression that is 0.58 degrees Celsius. We want to produce a freezing point depression that is 0.41 degrees Celsius. What is the value of X? Okay, or the percentage of sodium chloride that will produce that freezing point depression, 0.41 degrees Celsius. So this one is equal to 0.71 percent of sodium chloride. Okay. Now we have a 15 ml solution. So that's step number 3. Compute for the grams of sodium chloride. Okay. So we have 0.71 gram per 100 ml of the solution times 15 ml. So this is 0.1060 gram of sodium chloride. Okay. Now, we don't have sodium chloride. We have boric acid instead. Okay? So remember that the E value is the gram of sodium chloride per gram of the substance. So we can compute for number 4, the grams of boric acid. The grams of boric acid is 0.1060 gram divided by 0.52. So this will be equal to 0.2039 gram of boric acid. Okay? And so I will now leave you with this problem, okay, to compute the amount of 0.9% sodium chloride that will make the solution isotonic. Okay, and in order for me to move on to the next topic. Okay, so for our next topic, we actually have electrolyte solutions. So this will be our objective. So in this particular topic, we will be computing for the millimoles, milliequivalents, and milliosmoles. And we will apply our knowledge of isotonic solutions, okay, in this particular module, and solve for problems, okay, that would involve milliequivalents, milliosmoles, and millimoles. Ayan. So remember that, again, electrolytes are substances with varying degrees of dissociation. An example of electrolytes are actually those that are inorganic salts, okay, such as sodium chloride, potassium chloride, calcium chloride, sodium bicarbonate, basic sodium phosphate, monobasic sodium phosphate, and sulfate. Okay. Non-electrolytes are those substances which are not dissociated in solution, and examples of these are urea, dextrose, any other sugars like sucrose, glycerol, and other organic substances, okay, which are not ionized in a particular solution. So they are considered as non-electrolytes. Now, I will not actually discuss how to compute for the millimoles because that basically is discussed before. Okay, so if you will recall our discussion of molarity and normality, I have already mentioned these terminologies. Okay, and so molarity is remember that molarity is equal to the number of moles of a substance per liter of the solution. Okay. Now, the number of moles of the substance is actually equal to the weight of the substance in grams divided by the weight of the divided by the molecular weight of the substance in grams per mole. This molecular weight is also what we call the gram molecular weight. Okay. And now we can compute for the millimoles. Okay. And we can compute for the millimoles by simply multiplying 1,000 to this. Okay? Yeah, so we multiply 1,000 dun sa grams of the substance divided by the molecular weight of the substance in grams per mole. Okay, so why is that? It's because, hold on. This 1,000 is simply the conversion factor, okay, um, that converts your milligram to gram or vice versa. Okay? So ito lang talaga yung dahilan doon. Okay? So the number of millimoles therefore is equal to grams of the substance times 1,000 divided by the gram molecular weight of the substance. Okay? Yan. So 1,000 is actually the conversion factor. 1,000 milligrams are equivalent to a gram of the substance. Okay? Another thing that I want to point out is that the molecular weight, okay, that is in grams per mole is the same as the molecular weight in milligrams per millimole. Okay? That being said, the millimole can also be defined as the weight of the substance in milligrams divided by the milligram molecular weight of the substance, or the molecular weight of a substance na assuming it's milligram per millimoles. Okay? Ayan. So remember na in order for you to convert the weight of a substance from gram to milligrams, you need to multiply it by 1,000. So yun din yun. Okay? Ayan. So parehong-pareho lang yan. Now, what are milli equivalents? Okay, so you have seen this before. Yan, so para lang ma-jog yung inyong memory kung saan nyo to nakita nyo to sa normality. Okay, so normality is equal to the number of equivalents of the solute per liter of the solution. Okay, now I defined last time what number of equivalents are. And so the number of equivalents, okay, is equal to the weight of the substance in grams divided by the equivalent weight of the substance, or yung tinatawag nating gram equivalent weight of the substance. Okay? Yeah, so weight of the substance divided by the gram equivalent weight of the substance. Now, what is this gram equivalent weight? The equivalent weight is actually equal to the gram molecular weight of the substance divided by its factor. Okay? So the factor is dependent on the valence of the ions. Okay? Yan. So, for example, sodium chloride, um, in sodium chloride, the valence of both ions ay 1. Okay? So the factor is 1. Okay? Now, let's say naman for magnesium sulfate, the valence of magnesium is 2, the valence of sulfate is also 2. So the factor is 2. Okay? And so that's where we derive the factor. Okay? Now, what about this? What if we have dibasic sodium phosphate? Okay? Yan. And si monobasic sodium phosphate. Now, in this case, we have to take note which ion are we referring to. Okay, yeah. So it depends on which ion we are referring to. If we are referring to the sodium ion, then the factor is 1. Okay, but if we are referring to the phosphate ion, okay, the factor is 2. Okay, what I am saying here is that if you're asked to determine the the equivalent weight, okay, or the number of milliequivalents of the phosphate ion, okay, in your dibasic sodium phosphate, okay, then the factor will be 2. Okay? Kasi the valence of the dibasic phosphate ion is 2. Okay? But if you are asked to determine only the milliequivalence or the equivalence of sodium, then the factor is 1. Okay? Because sodium has a valence of only 1. Okay? How about this one? Here, sodium still has a factor of 1. And the monobasic sodium phosphate, H2PO4, has a factor that is equal to 1. Okay? Ayan. So, in that case, no, you have to take note which ion is being referred to, okay? Doon sa factor. Remember last time in my discussion, I only defined the factor, okay, based on acids and bases, okay? Sinabi ko na the factor of acids, okay, is basically the number of replaceable hydrogen ions in the acid, okay? So for example, hydrochloric acid has a factor that is 1. Sulfuric acid has a factor that is equal to 2. Okay? For bases, we base the factor on the number of hydroxide ions. Okay? So for example, sodium hydroxide has a factor equal to 1. Okay? And calcium hydroxide has a factor equal to 2. Okay? So the number of hydroxide ions, okay, is the factor for bases. For salts, okay? Yeah, so it's a little bit tricky, okay? So you have to consider the valence of the ions, okay? Now we will not have any problem, okay, if the valence of the ions, okay, is the same, okay, for both the cation and the anion, okay? Okay. So, for example, sodium chloride, both sodium ion and chloride ion has a valence of 1, so the factor is 1. For magnesium sulfate, both magnesium and sulfate um, have a valence of 2, so the factor is 2. Okay? It becomes tricky, okay, when we have salts like this, okay? For example, dibasic sodium phosphate and monobasic sodium phosphate. You have to consider what is being asked, okay? So, are you being asked the number of milliequivalents of sodium or the number of milliequivalents of phosphate ion, okay? Yeah, so you have to take note of that, okay? Yeah, so that being said, nakita nyo na before yung equivalence. Ito na yun. Okay? So equivalence, the yan, the equivalence, okay? The equivalence is equal to the weight of the substance in grams divided by the gram molecular weight of the substance divided by the factor. Okay? Now, remember na this is the same as weight in grams of the substance divided by molecular weight of the substance times the factor. Okay? Now, if we want milli-equivalents, then we have weight of the substance in gram divided by molecular weight times factor times 1,000. Again, The 1,000 is simply the conversion factor to convert gram to molecular weight. Okay? And so that is actually what we mean by milli equivalents. Now, these are some examples of ions in the body and their milli equivalents per liter. Now, remember that the cation ions and the anions in our body are balanced. Okay, so they have the same number of milli equivalents, approximately the same number of milli equivalents. Okay, yeah. So another thing that I want to mention here is that sodium is actually a major extracellular cation, and chloride is the major extracellular anion. Okay. And potassium is your major intracellular cation, and phosphate is your major intracellular anion. So here are the valences, okay, that you have to be familiar with, okay, in this particular discussion. Okay, yeah. So andito nakasulat lahat ng mga valences. So basically, ito yung sinabi ko kanina, no? Equivalent weight is basically the molecular weight of the substance, or the formula weight if we are referring the the cation or an ion divided by the factor or the valence of the ion. Ayan. So mas maganda mag-proceed na tayo doon sa calculations. Okay. So first problem is this. What is the concentration in milligrams per milliliter of a solution containing 2 milliequivalents of potassium chloride per liter? Okay. Now the molecular weight of potassium chloride is given and it is 74.5. Okay. Ayan. So let me begin by saying this. Okay. The molecular weight of potassium chloride is equal to 74.5 grams per mole. Okay, yeah. So remember that the unit of molecular weight is grams per mole. However, this is the same as 74.5 milligrams per millimole. Okay. Now, because we want to determine the number of milligrams, okay, per milliliter, okay, it is very useful to convert the molecular weight to milligrams per millimole. So this means that 1 millimole of potassium chloride weighs 74.5 milligrams. Okay? 1 millimole of potassium chloride weighs 74.5 milligrams. Yan na yung alam natin. Okay? What else do we know? Now, the salt, okay, has potassium ion and chloride ion. The valence is 1. So meaning to say 1 millimole of potassium chloride is equivalent to 1 milliequivalent. Okay? Yeah, so again, 1 millimole of potassium chloride is equal to 1 milliequivalent. The number here is actually the valence of the ion. Okay? And this is a constant. So ibig sabihin, 1 milliequivalent of potassium chloride weighs 74.5 milligrams kasi pareho silang equal to 1 millimole of potassium chloride. Okay? Now, we can actually solve for milligrams per milliliter equivalent to 2 MEQ by using the dimensional analysis. Okay? So, we have here 2 MEQ per liter. Ayan. So, per liter, i-convert na natin siyang milliliters. Ayan, para hindi na mahirap mamaya. Ayan, so, 2 MEQ of potassium chloride per 1,000 milliliters of the solution times, saan natin kukunin yung MEQ? 1 MEQ weighs 74.5 milligrams. Okay? And or para mas makita ninyo, ganito na muna. 1 MEQ of potassium chloride is equivalent to 1 millimole of potassium chloride. Okay? And we also know that the weight of 1 millimole potassium chloride is equal to 74.5, okay, milligrams. Okay? So therefore, we can now compute for cancel, milligrams per ml of your potassium chloride. And that is equal to 0.149 milligram per ml. Okay? So it's basically dimensional analysis. Okay? Makukuha ninyo na yung inyong makukuha nyo na yung amount in milligrams per ml equivalent to 2 MEQ per liter. Okay? So yan yung pinakamadaling solution that I can provide to you. Okay. So how about this one? What is the concentration in grams per milliliter of a solution containing 4 MEQ of calcium chloride dihydrate? Okay, 12 minutes. Okay, so the molecular weight is 147. So meaning to say 1 millimole of your calcium chloride has a weight of 147 milligrams. Now, 1 millimole of calcium chloride has 2 milli equivalents. Okay? So bakit natin nasabi na 2? It's because the valence of calcium ion is 2. Okay? Yeah, so it's positive 2. Ayan. So, the MEQ is actually being provided by calcium anyways. Okay, so we will base it on the calcium. Next is we will now perform dimensional analysis. So you have 4 MEQ. Okay, so 4 MEQ of calcium chloride dihydrate per milliliter times 2 MEQ equivalent to 1 millimole times 1 millimole has a weight of 147 milligrams. We will convert now the milligrams to grams. Okay, so this will be 1,000 milligrams, 1 gram. So this will be equal to 0.29 gram per ml. Okay, so next. A magnesium level in the blood plasma is determined to be 2.5 MEQ per liter. Okay? Express this concentration in terms of milligrams. Okay? And so again, we are given the atomic weight of magnesium. So 1 millimole of magnesium ion has a weight of 24 milligrams. Now I have 2.5 MEQ per liter. And so ito pala, i-convert ko muna. 1 millimole is equal to 2 milli equivalents. Okay? Yeah, so saan ang galing yung 2 milli equivalents? 2 being the valence of magnesium. And so 2 MEQ yan, is equivalent to 1 millimole. 1 millimole has a weight of 24 milligrams. Ayan. So, it's already in milligrams. Ayan, ang tanong ay convert this in terms of milligrams. Okay, so yan na yun. So, we have 30 milligrams per liter. Okay, so this will be our final answer. Now, you can also use, by the way, ratio and proportion. Okay, because we already know that 2 MEQ, right? We already know that 2 MEQ has weight of 24 milligrams. Saan nanggaling yon? Ayan, nanggaling yon dito. Okay, 1 millimole is 24 milligrams. 1 millimole is 2 MEQ. So, ibig sabihin, 2 MEQ of magnesium has a weight of 24 milligrams. Now, if you have 2.5 MEQ of the same substance, what will be its amount in milligrams x? Okay, so we compute for the value of x. We simply move this here. Ito din yon. Ayan, so the answer is 30 milligrams. Okay, now both are in per liter. So this is per liter. So this will be per liter as well. Ayan, so how about this one? How many milliequivalents of magnesium sulfate are represented in 1 gram of anhydrous magnesium sulfate? Okay, so ganun pa rin yung gagawin natin. Ayan, so we have 1 millimole of magnesium has a weight of 120 milligrams. Okay, 1 millimole of magnesium sulfate is equivalent to 2 MEQ. Okay, next is we have 1 gram of anhydrous magnesium sulfate. And so we have 1 gram of anhydrous magnesium sulfate. And we know that 2 MEQ is equivalent to 120 milligrams. Okay. Yeah, so 1 gram, convert muna natin siya sa milligram. So 1 gram is 1,000 milligrams. Ayan. So 120 milligrams are contained in 2 milliequivalents of your magnesium sulfate. Okay? So we now have this. So the answer is 16.67 MEQ of magnesium sulfate. Now you can also use the formula that we have. Okay? So remember yung ating formula kanina na binigay ko. The number of milliequivalents is equal to the weight of the substance in gram divided by the gram molecular weight, okay, times 1,000 times the factor, okay, or the valence. So the MEQ therefore is equal to the weight in grams, 1 gram, divided by the molecular weight in grams per mole. So 120 pa rin naman yun, grams per mole. Yan, times 1,000 times the factor, that is 2, you should get the same answer. Basically, yun din yun. So MEQ is equal to 16.67 MEQ. Okay? Yan. So how about osmotic pressure? Okay? So remember that osmotic pressure is the minimum pressure which needs to be applied to a solution to prevent the inward flow of its pure solvent across a semi-permeable membrane. Um, just like what we discussed before, osmotic pressure is dependent on the number of particles in the solution. Okay, and not necessarily the type of the solute that we have, but the total number of the particles in the solution. And osmotic pressure can be measured in terms of milliosmoles or osmolarity. Okay, yeah. So osmolarity is actually your milliosmoles per liter. Okay, so the osmotic pressure is different for non-electrolytes and electrolytes just because of the fact that electrolytes dissociate in solution. Okay. Ayan. So remember your colligative properties. Ayan. So nakita niyo na to before. So let's just move on to the osmolarity. Okay. So osmolarity is basically the milliosmoles of the solute per liter of the solution. This is the formula, but I don't normally memorize formulas. So I will show you a different technique of computing the osmolarity or the number of milliosmoles without using any formulas later on. Okay. And it's basically the same. Okay. And dapat nyo lang tandaan, weight pa rin to divided by molecular weight times, dito lang tayo nagkakaiba, in MEQ, okay, this is valence, okay? Pero in osmolarity, this now becomes the number of species, okay? And or the number of particles, okay? Or the number of ions, okay, that will be present in the solution, okay? Yan, times 1,000, 1,000 being the conversion factor from grams to milligrams, okay? Osmolality is similar to your molality. It is based on a kilogram of the solvent. And so let's compute for the osmolarity of the following examples. Ayan, so we have dextrose, 5% anhydrous dextrose in water for injection. How many milliosmoles per liter are represented by this concentration? Ayan, so again, we begin with your molecular weight. Ayan, so since milliosmoles yan, I will start with 1 millimole. Okay, so 1 millimole has a weight of 180 milligrams. Okay, next. Um, 1 millimole has a weight of 180 milligrams. And because I have a non-electrolyte, 1 millimole is equal to 1 milliosmole. Okay? Yan. So dito tayo nagkakaiba. Ito yung maaaring magbago. Okay? If you have a non-electrolyte, this is 1. Okay? If this is an electrolyte, this can be 2, this can be 3, and so on, no? Depending on the number of the particles or the ions in the solution. Now, we don't count, okay? We no longer count the undissociated particles, no? Ang kinakount lang natin usually ay yung number of ions, okay? Yan kasi the typical assumption here is that in electrolytes, okay, they actually dissociate completely. Okay, walang undissociated particles, okay, in the solution. Ayan. So basically, we have a non-electrolyte. So 1 millimole of the substance is the same as 1 milliosmole. Okay? The next thing that we will do is we will determine how many grams of the anhydrous dextrose are present in a liter. Okay? So 5 grams are present in 100 milliliters. Okay? Now, if we will convert this to a liter, okay, so we multiply this by 1,000 milliliters. So we have 50 grams of dextrose present in a liter of the solution. Okay? And so now that we know this, okay, we know the amount of the solute, 50 grams of dextrose, okay, in the solution, ko-convert natin siya into milligrams. And so 50 grams, convert natin sa milligrams, 1,000 milligrams. Now we know that 180 milligrams represent 1 millimole of dextrose. And we also know that 1 millimole of dextrose is 1 milliosmol. Okay? So we cancel grams, milligrams, millimole. We actually have milliosmol per liter. Yun na lang yung naiwan. Okay? So the answer will be equal to 277.8 milliosmoles per liter. Okay? Now, you can also use our formula. Okay? So remember the formula for milliosmolarity or the osmolarity. It's the weight of the substance, 50 grams, divided by its molecular weight, 180, times the number of particles, 1, okay? And multiply it by 1,000, our conversion factor, basically ito rin yun. So you get 277.8 milliosmoles per liter. Okay? Yan. Now, you may wonder, the one that is present in your dextrose, the one that is infused, no, for for replenishment and for nutrition, is this, no. Ayan. So we have 5% of dextrose in water. Okay, you can actually see the milliosmoles per liter, okay, in the label of your solution. Okay, so you will find here na its milliosmoles per liter is actually equal to 252 milliosmoles per liter. Why is there a difference? No? Tayo, ang na-compute natin, let me just rewrite what we computed. 50, okay, grams divided by 180 times 1,000 times 1. This is 278, no? About 278 or 277.8 milliosmoles per liter. Okay? So what's the difference? Okay, so bakit dito sabi 252 milliosmoles per liter daw siya? It has something to do with the dextrose. Okay, the dextrose that is contained in this solution is dextrose monohydrate. Okay, yeah. So it is dextrose monohydrate. Now what we have here is anhydrous dextrose. So dahil doon magkaiba sila ng molecular weight. The molecular weight of dextrose monohydrate is actually equal to, hold on, I took note of it. It's equal to 198.17 grams per mole. Okay? Ayan. Now, assuming that we also have 50 grams, okay? We also have 50 grams of dextrose monohydrate, okay? In a liter of the solution, what will be the number of milliosmoles per liter of dextrose, okay? Yeah, so 50 grams divided by its molecular weight. This time I will use 198.17 times 1,000 times 1. This should be equal to 252 milliosmoles per liter. Okay? Ayan. So sana nag-gets nyo. Alright, so moving on. A solution contains 156 milligrams of potassium ions per 100 milliliters. How many milliosmoles are represented in a liter of a solution? So liter yan. We have the atomic weight. So meaning to say 1 millimole of potassium has a weight that is equal to 39.1 milligrams. Okay? Yeah, so this is from the atomic weight of potassium. Now, 1 millimole of potassium has has an equivalent of 1 milliosmol. Okay? Ayan. So bakit natin nasabi 'yon? Kasi um, we only have potassium ions. Okay? Wala na siyang ibang kasama. Okay? So 1 pa rin 'yan. Okay? So hindi natin siya babaguhin. Okay? So next is we are given this 156. So 156 milligrams of potassium ions are contained in 100 milliliters of the solution. Now, just to remove all confusions, convert na natin siya to liters. Ayan, kasi yun naman yung tinatanong, how many milliosmoles are represented in a liter of the solution? And so I have placed here the conversion factor. Next is, we know that 1 millimole of potassium ion weighs 39.1 milligrams. Okay? And next, we know na 1 millimole of potassium ion is equivalent to 1 milliosmol. Okay? So the answer should be 39.9 milliosmoles per liter. Okay? Yeah, so of course, you can still use our formula. Okay? But if you will be using our formula, make sure that the weight is in 1 liter. Okay? Yeah, so 156 milligrams are equivalent to 0.156 gram. Okay? 1, 2, 3. Okay? So 0.156 gram, okay, are contained in 100 milliliters. Now, in 1 liter, how many are contained? Okay, so we multiply this by 1,000 ml per liter. So this will be 1, 2, okay. So cancel, cancel. Ayan. So 1.56. So this is 1.56 grams per liter. Okay. Now the milliosmoles per liter will be equal to this one, 1.56 grams per liter divided by this, the molecular weight, 39.1, okay? Or the atomic weight, I mean, times 1,000, the conversion factor, times number of particles, 1, okay? Yeah, so it should give you the same answer, 39.9 milliosmoles per liter. Okay. Ayan. So how about this one? Ayan. So we will not be solving this anymore. Ayan. Sige, solve na lang natin siya. The atomic weight is 40.08. No? So 1 millimole is equal to 40.08. Ayan. Now 1 millimole is equal to 1 milliosmol. Ayan. What? Ayan. Bakit 1? Eh, 2 yung valence niya. Okay? Yeah, so this is the most common misconception of students. Okay? Ayan. So remember that the milliosmol does not depend on the valence, no? It is the milli equivalence. Okay? Ayan. So yan yung pinagkaiba ng dalawa. Okay? Ayan. So 1 millimole of calcium ion weighs 40.08 milligrams. Okay? 1 millimole of calcium ion is equivalent to 1 milliosmol, and it is also equal to 2 milliequivalents. 2 coming from the valence of the calcium ion. Okay? Yan. So take note. Yan. It's still 1 milliosmol here. Okay? Now, this is 10 milligrams percent. So, ibig sabihin, 10 milligrams are contained in 100 milliliters times 1,000 ml per liter. So, this will be equal to, ayan, wag na nating i-equal yan. Ayan. Anyways, milligrams na yan. Milligrams. Ayan. So, milligrams na yan. So, this is yung milligrams. Kukunin natin. 40.08 milligrams. This is the weight of 1 milliosmol. Ayan. Mag-shortcut na tayo. Ayan. Because same lang naman to. Ayan. So, I can say that 1 milliosmol weighs 40.08 milligrams. Okay. So, I now have a value that is equal to 2.5 milliosmoles per liter. Okay? Now, we can solve also for the MEQ. Okay? Ayan. So, kung gusto ninyong isolve yung MEQ niya, ganun pa rin, 10 milligrams divided by 100 ml times 1,000 ml divided by 1 liter times 2 MEQ weighs, ayan, 40.08 milligrams. Okay? So, this is the this is the equivalent weight, okay, of your substance. Yeah, so this will be equal to, ayan, just multiply this by 2. So this will be 5 MEQ per liter. Okay? Ayan. So yan yung pinagkaiba ng milliosmol and milliequivalents. And how about this one? How many milliosmoles are represented in a liter of 0.9% sodium chloride? So 0.9% is 0.9 gram per 100 ml times 1 liter ulit, so 1,000 ml per liter. Ayan, times, next that we will do, I will convert this to, pwede ko siyang i-convert to milligrams. Okay, so convert ko sa milligrams, 1,000 milligrams. Okay, and then 58.44 milligrams. Okay, this is the weight of how many milliosmoles. Ayan, pupunta tayo dito. 1 millimole of sodium chloride weighs 58.44 milligrams. Now, 1 millimole of sodium chloride is equivalent to 2 milliosmoles. Okay? Saan ang galing yung 2? Ayan. It comes from sodium ion and chloride ion. Okay? So, kaya yan, 2. So, we can say that the weight of 2 milliosmoles ay 58.44 milligrams. Okay? Yan. So, na-shortcut na natin yan. So, the answer is 308 milliosmoles per liter. Okay? Well, you can also use the formula. Okay? Yan. So, pag gagamitin natin yung formula, 0.9 gram is contained in 100 ml times 1,000 milliliters. So, that will be 9 gram contained in a liter. Okay? Divided by the molecular weight. So, this is 58.44 times the number of particles, 2, times the conversion factor, 1,000. Yan. So it should give you the same answer, 308 milliosmoles per liter. Okay? Yan. So that's how we compute for the osmolarity of your normal saline solution, which is actually written also in the label of your normal saline solution. Okay? Now, this is important, no? Our osmolarity is important because we know that water is the most common environment where cells live, and it is the primary medium for the ingestion of nutrients and for the excretion of metabolic waste products. The osmolality of body fluids is maintained within narrow limits through the following processes, no? Through dietary input, whatever thing that you eat, through regulatory endocrine processes. For example, our micturition or our urination. Ayan, gusto ko tong term na to, micturition. Yan, or basically urination. Yan, sa pag-ihi natin, okay? Yung pag-ihi is actually controlled by endocrine processes, okay? Yung ating tinatawag na renin aldosterone system, okay? Ayan. So this actually controls the amount of fluid that we will excrete, no? Depending on the number of electrolytes present in our body. Okay? Kasi if you are severely dehydrated, okay, you will not actually try to excrete, okay, the fluid in your body anymore. Okay? But if you ingested a sufficient amount of water or more than the sufficient amount of water, then your endocrine system will tell you to excrete that excess water. Okay, yeah. So there is balance, no, inside our body, and it's controlled by endocrine processes. One of which is your renin aldosterone system. Actually, meron pa yan. Renin angiotensin aldosterone system. And of course, through balanced output via the kidneys, lungs, skin, and the GI system. And so take note of this, that the amount of fat in the body will actually also control the amount of water that we have. No, remember now, water and oil does not mix. So the higher the amount of fat that you have, the lower will be the water that is contained in your body. Okay. Now we have the following average ranges of total body water. And take note that of the adult's body water content, up to two-thirds is intracellular and one-third is extracellular. So extracellular fluids are those that are considered as intravascular, so meaning to say nasa blood vessels, and in between of the cells, or yung tinatawag nating interstitial fluid. And so these are just some of the diagrams to show you where those are. And so we have here um, insertish, interstitial fluid, okay? Interstitial fluid. Yeah, so the one that is in between the cells, okay? We have intravascular fluid. Ito yung ating extracellular, I mean, fluid. And we also have intracellular fluid. And now, these are the occasions where you need fluid and electrolyte therapy, no? And it's to provide maintenance requirements and to replace serious losses or deficits, which can actually happen when you have the following conditions like vomiting, diarrhea, profuse sweating, fever, chronic renal failure, or diuretic therapy, surgery, among others. Okay. For example, if you have a trauma, no, if you are a burn patient and you have trauma, okay, meron kang severe burning of the skin, okay, you will also have excessive loss of water. Okay, and so that's one condition where fluid and electrolyte therapy is indicated. And so these are some of the things no na you are not really required to memorize. Nasabi ko na to kanina. And so plasma osmolality can be computed. Okay? So plasma osmolality is the number of milliosmoles per kilogram, okay? And it is computed as the concentration of sodium and potassium ion in MEq per liter times 2, and BUN in milligrams per DL divided by 2.8. Glucose, ganun din, milligrams per DL divided by 18. Ayan. So, basically, we just use this formula to compute for the plasma osmolality. Okay? Yeah, so ganito lang naman yan, 2 times the sum of the MEq per liter of sodium and potassium. So 135 MEq per liter plus 4.5 MEq per liter. Ayan. Plus the BUN, 14 milligrams per DL divided by 2.8 plus glucose 90 milligrams per DL and divided by 18. So the plasma osmolality, okay, is actually equal to 370 milliosmol per kilogram. Okay? Ayan. So just use the formula. So napakawalang kwentang problem. Okay. So this will be our last slide, no? Overtime na ako. Ayan, pero we'll just summarize everything through this particular problem. Okay? And I want you to work with me here. Okay? Ayan, so calculate the number of milliequivalents of sodium, potassium, and chloride, and the millimoles of anhydrous dextrose, and osmolarity of the following parenteral fluid. Okay? So this is a very common parenteral fluid. Okay? One that contains sugar for nutrition, and there are electrolytes. Okay? So ito yung electrolytes na contained in the solution. Okay? So of course, the sugar is an energy source for the patient. Okay? And meron kang electrolytes to replenish whatever loss in electrolyte meron yung patient. Now, normally kasi when a patient is severely dehydrated, the patient will also lose electrolytes. Kasi together with the water, ay sumasama yung mga electrolytes. That's the reason why we need electrolyte therapy, no? If a patient is dehydrated. Um, Actually, it's contraindicated to give only water to a patient who is dehydrated. Okay? Kasi magkakaroon ka ng shock in the patient. Okay? Kasi lalo mo lang patataasin, okay? Lalo mong patataasin yung plasma volume of the patient, yung concentration of electrolyte will drop. Okay? Pag bumagsak yung concentration ng certain electrolytes like potassium, which is a very important electrolyte, pwedeng magkaroon ng problem sa heart. Okay? Yan. So, potassium controls the function of the heart as well, okay? And also calcium, okay? So kapag kunwari binigyan mo yung isang severely dehydrated patient ng water only, okay? Without electrolytes, okay? Pwedeng magkaroon ng cardiac arrest yung patient, okay? And it is because of increasing the plasma volume of the patient, um, resulting in a drastic decrease in the electrolyte concentration. Okay? Biglang bumagsak yung potassium concentration level and yung calcium concentration level, yung patient ay biglang masashock. Okay? Yeah, magkakaroon siya ng cardiac arrest. Okay? Kaya ang dapat, binibigyan yung patient um, ng fluids containing electrolytes as well. Okay? So, I want you to work with me here. Okay? So, calculate the number of milliequivalents of sodium, potassium, and chloride. Okay, ayan. So, we are given the following. So, let's begin with sodium. Ayan. So, to determine the amount of sodium, ayan, ito pala yung ito yung confusing usually, no? Ayan. So, you are given here 4.5 grams of sodium chloride. Okay? Kaso, ang tinatanong ay number of milliequivalents of sodium. Tapos binigay ko pa yung atomic weight. Okay? Do you think we will actually be, do you think, how do you think we're going to use this amount, no? Yung atomic weight of your sodium. Okay? And so remember na 4.5 grams of sodium chloride can be converted to number of moles. Okay? And so 4.5 grams times, yan, the molecular weight of your sodium chloride is 58.44 grams, okay, per mole. Ayan. So, ibig sabihin nito, 1 mole of sodium chloride weighs 58.44 grams. Okay? Next, we know that in 1 mole of sodium chloride, yan, lagyan natin ito ng sodium chloride para maliwanag, yan, also contains 1 mole of sodium ion. Okay? Yan, so, naglalaman din siya ng 1 mole of sodium ion. Now, do I need to use the atomic weight of sodium? Okay? Yeah, so look at what I'm going to do. Ayan. Pwedeng oo, pwedeng hindi. Pero it is absurd to use the atomic weight. Okay? Do you know why? Ayan, so we already have 1 mole of sodium here. And I can already convert 1 mole to millimoles. Okay? So 1 mole of sodium ion is equivalent to 1,000 millimoles of sodium. Okay? And so at this point, nagka-cancel out pa lahat, no? Nag-cancel to, nag-cancel to, nag-cancel to. Okay? So now I have 1,000, okay, millimoles of sodium times 4.5 divided by 58.44. Okay? Now, I know na I want to compute for the MEQ. I know that 1 millimole of sodium ion is equivalent to 1 MEQ of sodium. Okay? So without using 23 grams per mole, which is the atomic weight of sodium, I can actually compute for the MEQ of sodium ion. Okay? Yan. So, nandito na ako sa MEQ of sodium. Yan. So, wala na akong problema. Yan. Computing ko na lang yan mamaya. So, next. How about the MEQ of potassium? Okay? So, for potassium, ganun pa rin yung gagawin ko. I have 1.49 grams of potassium chloride. I will multiply it by the molecular weight, not or actually the inverse of the molecular weight of potassium chloride, 74.55 grams of potassium chloride, 1 mole of potassium chloride. Times, I know that 1 mole of potassium chloride contains 1 mole of potassium ion. Okay? Now, this is just a conversion factor, converting 1 mole of potassium to millimoles. And then, I also know that 1 millimoles of potassium ay 1 milli equivalent of potassium. Okay? Yan. So, tingnan ninyo kung gaano nakalayo nakarating yung inyong dimensional analysis. Okay? Yan. So, this is a simple problem, okay, using only dimensional analysis. Okay? Yeah, so now we have the following answer. So, 4.5 times 1,000 divided by 58.44. So, this is equal to 77. Okay, so this is 77 MEQ of sodium. Okay, next, how about this one? 1.49 times 1,000 divided by 74.55. So this is equal to 19.99, okay, MEQ of potassium, or simply 20 MEQ of potassium. Okay? Now, remember the formula that I gave you, okay? So yung formula na binigay ko sa inyo about MEQ is this. MEQ is equal to the gram molecular weight, the weight of the substance divided by the gram molecular weight of the substance times 1,000. Okay? Yan, notice, yun din yun. Okay? Yung ginawa natin dito. Okay? Yan, so MEQ of sodium, okay, is the weight of the substance, 4.5, pero it's sodium chloride. Okay? Now, because of this, no? Ayan, pansinin nyo to. And because we know that 1 mole of sodium chloride contains 1 mole of sodium ion, okay? Ibig sabihin, we can use the weight of sodium chloride here, okay? And the molecular weight of sodium chloride here to compute for the MEQ of sodium here, okay? Yan, so yun lang yung gusto kong i-point out dito, no? Pwede niyong makompute yung MEQ of sodium ion, okay, using the weight of the substance as long as you also use the molecular weight, okay, of the substance, not the ion, okay, or not the atomic weight of sodium. Okay? Ayan, so yun din yun. So 77 MEQ of sodium and 20 MEQ of potassium. Okay? Now, the next is you are asked to determine the calcium naman. Okay? So determine the MEQ of calcium. Now, ito na naman yung kailangan ninyong i-observe. Notice that 1 mole of sodium is equal to, sodium chloride na muna. 1 mole of sodium chloride is the same as 1 mole of sodium, or 1 mole of sodium chloride contains 1 mole of sodium and 1 mole of chloride. So, 1 MEQ, okay, of sodium will also be equal to 1 MEQ of chloride. Okay? So, meaning to say, in your 4.5 grams sodium chloride, you have 77 MEQ of sodium and 77 MEQ of chloride ion as well. Okay? The same is true for your potassium. Okay? 1 MEQ of potassium is the same as 1 MEQ of chloride. So you also have 20 MEQ of chloride here. Okay? So the total number of chloride is simply the sum of these two. Okay? Yan. So we just get the sum. So we get 77 MEQ chloride plus 20 MEQ chloride. So that's equal to 97 MEQ of chloride. Okay? Yeah, so nasagutan na natin yung tatlo. Okay? Now, the next question is, compute for the number of millimoles of anhydrous dextrose. Okay? Ayan, so dito na lang ako magsusulat. Number of millimoles daw of anhydrous dextrose. So we have 50 grams or 50 grams of your dextrose. Okay? I will simply use dimensional analysis para makita ninyo yung universality of this particular technique. Okay? Kaya nga sinabi ko pa lang sa start ng ating term, okay? Make sure that you understand how to use the dimensional analysis. It will take you until the very end of this lesson, of this lecture. Okay? So 50 grams of dextrose, we just convert this to milligrams. And then, given yung molecular weight niya, 180 milligrams per millimole. Ayan. Okay? Ayan. So, pinalitan ko yung grams per mole dito ng milligrams per millimole kasi it's the same. Okay? Ayan. So, 50 times 1,000 divided by 180 is equal to 278.78 or 0.8 millimoles of dextrose are present in the solution. Okay? Ayan. So sana na-gets nyo yung part na yan. The next thing that you will do is compute for the osmolarity. Okay? Yan. Osmolarity daw of the solution. Ayan. So I need to remove everything. Now, the thing about osmolarity is that you can actually add. Okay? Yan. So, unlike millimoles and milliequivalents, yan, pwede ninyong i-add yung milliosmolarity if it comes from different sources. Okay? Yeah. So, again, ulitin ko, no? Remember that osmolarity is only dependent on the number of particles. It is not dependent on the type of solute that is present. It is only dependent on the number of particles. So kahit na sino pa yan, okay, you can add their osmolarity, no? Or their milliosmoles per liter. Okay, so yun yung gusto kong i-point out dito, no? Unlike your MEQ and your millimoles. Okay? Yung MEQ, dapat ang ina-add nyo lang ay yung same substance. Okay? For example, yung ginawa natin, we added the MEQ of chloride coming from sodium and the MEQ of chloride coming from potassium chloride, okay, to get the total number of MEQ of chloride. Pero when it comes to osmolarity, you can add everything. Okay? Yeah, so what we just need to do is to compute for the um, osmolarity, okay? Kailangan lang natin i-compute yung osmolarity of each of these substance and add, no? I-add lang natin sila together. Ayan, so magsimula ako sa dextrose na lang. So I have dextrose, so 50, okay, 50 grams of dextrose in a liter and divided by 180.16 grams per mole times the number of particles, so 1 times 1,000. This is the milliosmoles contributed by dextrose. Okay, so 50 times 1,000 divided by 180. This is 277.8 milliosmoles per liter. Okay? Ito yung kino-contribute ng dextrose. Okay? Next, how about si sodium chloride? Si sodium chloride, 4.5 grams. This time I will be using the formula. Okay? Anyways, you will notice something na surprising. 4.5 grams of sodium chloride divided by the molecular weight, 58.44 times the number of particles, okay, 2. Sodium chloride yan, dalawa yung particle, sodium and chloride, times 1,000. So the number of milliosmoles per liter is 4.5 times 2 divided by 58.44 times 1,000. So it's 154 milliosmoles per liter. This one is contributed by sodium chloride. Okay? Next, I have 1.49 gram of potassium chloride. The molecular weight is 74.55 times 2 pa rin. This is the number of particles in potassium chloride times 1,000. And so this will be 1.49 times 1,000 divided by times 2 divided by 74.55. So this will be equal to 39 or 39.97 or simply 40. Okay? 40 milliosmoles per liter. This one is contributed by potassium chloride. Okay? Now remember that osmolarity only depends on the number of particles, not on the type of the solute. We can add them together. Okay? So add 39.97 or 40 plus 154 plus 277. It will give you the total osmolarity that is equal to 470.97 or 471, okay, milliosmoles per liter. Okay? Ayan. So that is the osmolarity of the parenteral fluid. Okay? Yan. So kaya ito yung final problem ko kasi this now illustrates everything that you should have learned at this point, no, of the discussion of our pharmaceutical calculations. Okay? Yeah, so with that we end, okay, our lesson. And so I'm sorry that we had to have an overtime